So let's go ahead and start this. Okay, so hopefully you've had the chance to get Java installed on your system. If you haven't, please let me know. And if for some reason you're still having issues with IntelliJ, then I suggest trying maybe Eclipse or something. As it stands, though, I'm going to assume right now that you're at a point where you can be coding now. So when we left off, we had created our Rabbit class, we started our Rabbit off, and right now Rabbit does something at random. Right now, as far as this goes, we have a loop now that says for I in model.min direction. Now model.min direction, what I'm going to do here is I'm pressing control and I'm clicking, which pops me right to where that variable is referenced in the code. Right, that 0 and model.max direction is 7, which just simply iterates through north, northeast, east, southeast, all of our directions going clockwise. Okay? And then it's saying if look is equal to model.fox, which again is an integer. So these are all integers it's checking around when it's returning stuff. And the reason for that is that it's easy to write the return values there. But more importantly, because we have these final static variables, we can just reference them incredibly easily by just going model.fox. So if look_i is a model.fox, we want to do something. So right now, let's go ahead and just kind of show you how that would work. What I could do is I could say, hey, if I see the fox, run straight towards the jaws of death. Which is just, and to do that, we would just simply return I. Obviously, this is not a winning strategy in the slightest. In fact, it's the opposite of winning strategy. It is the kind of strategy that would get you tossed off a team. But right now, he's going to stay still, and now see, he is running towards the jaws of death. And he lost, unsurprisingly. Okay. So now, we probably would like to go the other way, right? Not towards the jaws of death, away from the jaws of death, right? So we can, so the key to that, as I mentioned yesterday, was model.turn. So what we can do is use something called model.turn, and as I explained yesterday, last time, model.turn takes in two variables. That direction, which is I, and a number, which is the number of 45 degrees turn you want to make relative to that direction. This function is essential because if you don't use it, you're going to have 8 different scenarios, one for each direction that you see the fox in. So if this direction is I and 1 will be this direction, I and 2 will be this direction, I and 3 will be this direction, 4 would be directly away, 5 would be away and to the left, 6 would be directly to the left. So if I put in 4, like right over here, then we can run this, and this is actually going to go, our rabbit isn't going to do anything. Why isn't he doing anything? He's at an edge. Yeah, he's at a wall. Okay, he has nowhere to go. So let's go ahead and see this again. Okay. So perhaps we can see this with a bit more. Okay. Stop, reset. Okay, now we go. Got something. Okay, and now sees each other, runs, and wham, he hits the edge. Now, not necessarily the greatest strategy in the world right there. So notice that I'm not telling him to stay still though. I'm still telling him to move in a certain direction. If you tell him to do an illegal move, okay, he is going to this rabbit is going to stay still if you do an illegal move. If on the other hand, so So doing an illegal move and model.stay, those are the exact same things. So if you tell them to go into a wall or bush, it's not going to work. So we probably want to do something other than just directly away, because eventually because we're staying in line of sight of the fox. And unless we actually want that to happen because we're doing a kiting strategy, we probably want to be out of the line of sight. Okay. Now with regards to doing that, right? So staying out of line of sight, you got to figure out which directions you want to use. Okay. Furthermore, we want to probably, have some alternatives, right? For instance, if I see the fox, I'm going to dodge to the left. If I can't go to the left, I maybe want to go to the right instead, So there's another function in model called model.canMove, or sorry, not model. It's not model, it's an animal. So it'd be this.canMove, because this is an animal, and so it has access to all the animal functions. And canMove simply says, hey, if I can move in this direction, return true. Otherwise, return false. And you can't move in that direction if there's a wall on an edge, right next to you in that direction. So if you're thinking about it, then basically within this if statement, you'd have a bunch of other if statements for the directions you'd want to try. Okay. Does that make sense to everybody? Yes.
Question regarding the this dot. So why didn't we use it for the look function, but we did use it for the can move function?
Because I felt like it.
Okay, but you don't need to.
You
right?
don't need to.
Okay. I'm just trying to remember object-oriented programming.
So in some programming languages, the keyword this to refer to instance methods is required. Like in Python, you have to do self dot something in order to call it as a method. But on the other hand, in Java is useful because it will infer a lot of things for you. So you can just do look. We can just do can move, but I wanted to explicitly do the autocomplete like this to pull it up with all the other stuff that it had as an animal. So this dot can move, because this dot would let you see all the things that you get, including all these things that you get from object.
Like if you wrote like rabbit.canMove.
If you wrote your own can move function, it would override
right.
your function of the function in animal. So it would be called instead of the animal function. So, but anyway, in here you'd want some if statements about which way you can move, and some alternatives about that. Now, also I should mention is that the fox has a bias in terms of direction. You will get a dramatically more success. Your success rates will vary dramatically based off of whether you're based off of which directions you try first, even if the directions are symmetrical. So left versus right and right versus left will give you vastly different results because of the way the fox moves. Right? Let's go over to the fox again. Right? This is his pacing code, which is that he says if I don't see the fox, if I'm actively looking for the rabbit now, and remember the fox actively has to look for the rabbit. Rabbit just has to stay still because he doesn't want to look for the fox. If he looks for the fox is going to see him. So if I can move in the current direction, I do. If I can't, I try to go into that direction, and current direction number 1 means I am looking this way, and so I'll go this way. And if I can't do that, then I'm going to go this way. Otherwise, I'm going to choose a random direction to start out with and try to move in that direction. And then rotate clockwise till figure out a direction to go. Okay? Now, so the fox does have a bias. So the fox has a bias, and so you'll want to write that into your if statement. So your two tools are the can move paired with an if statement and a model.turn. In fact, you'll probably want to combine those statements in your if statement. So, and you should be able to get, and if you with the right variables, you can get up to around the 90 percentile survival rate. To get above that, okay, you need to So at that point, to get above that, what you have to do is you have to start accounting for those cases where you're going to get caught. Okay? So this, now, another thing about the grader. The grader is a square root, does a square root curve. So that means that the grade it gives is your survival rate, it's the square root of your survival rate, divided by, the square root of your survival rate multiplied by 10. So if, for instance, you have a survival rate of 64, that's going to get you an 80. Because 64 divided by square root of 64 is 8, multiplied by 10, you've got an 80. So 64 gets you percent survival rate gets you a B, and 81% survival rate will get you an A. Beyond that, the returns are seriously diminishing, so just keep that in mind. It's a cost-benefit analysis as to how much time and effort you want to put that into that for the first week. Most other assignments you'll be able to get 100 on, and then I fudge this a bit more by adding 20 points for demoing. Because again, most of the assignments, if you do them correctly, you'll get 100 points on them. Okay. So that's really all I have for lecturing today because, again, I like to see what you're doing and to help you out. So any other questions before I start going to individual students? All right.